Hi everybody, welcome back and welcome to our fourth lesson in this topic, and the title of today's lesson is pressure in the atmosphere. And by the end of the lesson, hopefully you'll be able to describe the relationship between pressure in the atmosphere and height from the ground. As always, before we look forward, we're going to look back and ensure that we understand the content from the previous few lessons. So there are two questions on the screen. Please pause the video now and answer those questions on paper, and we'll check your answers in a minute. Okay then, how did you do? So the first question says a boy is walking on a frozen lake and he hears it begin to crack. Obviously he's going to panic. Should he stand on one foot or should he lie down on the ice? Explain your answer. Well, he should lie down, and the reason for that is whether he's stood on one foot or he's laid down, his weight is going to be the same in both situations. But when he's laid down, the area over which his weight is exerted is greater, and therefore the pressure will be lower, giving him a better chance of survival and not falling through the ice. The second question says, what is the relationship between pressure and depth in water? And the answer to that is the pressure in water increases with depth. Remember the question I set you at the end of last lesson about the dam wall? The wall of a dam should be really thick at the bottom, because if you go deep into that dam, deep down in the water, the pressure becomes so great that it could break the wall if it's not thick enough. So imagine you stood outside and it's not a windy day, so I don't want you to think about wind as being pressure in the air. But imagine you stood outside. Can you feel the air attacking your body? Can you feel the pressure of the air on your body? Probably not. But that air does have pressure and it's coming from all directions onto your body. A good way of visualizing this idea of air pressure is to consider this example. Now imagine yourself stood on the top of Mount Everest. Yeah, you're 28,000 feet up in the air. And imagine yourself stood at the bottom of Mount Everest, right? So you're on ground level. Now, obviously, if you stood on top of that mountain, there is some air above you, but not much. So the air pushing down on you is not that great. The pressure of the air is not that great. But if you're at the bottom of the mountain, you've got all the air in the world above you, and it's pushing down on you. So there is a relationship between air pressure and altitude. Altitude means height from the ground. So the weight of air is greater at low altitudes, so the air pressure is much greater. And although you might not feel it, it's definitely there. It's not good me just saying that though, is it? We need to think of different situations where we can see it rather than feel it. So let's think about a balloon, and you blow up this balloon. And if you blow up that balloon, there's air inside it. And that air, the particles of that air, are pushing against the balloon and they're keeping it inflated. But the balloon keeps its shape, doesn't it? And the reason it keeps its shape is because there's air on the outside of that balloon. And that air is pushing with the same pressure as the air on the inside. So therefore, if the air pressure inside the balloon is equal to the air outside the balloon, it's going to keep its shape. Now, over time, some of that air on the inside of the balloon will probably escape through the skin of the balloon. And therefore, the amount of air inside and the pressure of the air inside will begin to decrease, and you'll notice that the arrows that I've drawn this time are a little bit smaller. But on the outside, the air pressure is still the same. So what do you think would happen to that balloon? It's what happens to every balloon usually over a period of time. It would start to deflate like that, wouldn't it? And you've all done that thing where you brought a balloon home from a party and you've left it at the back of the couch in the front room, and a few days later it looks like the one at the top of the screen rather than the big balloon that you brought home. And the reason for that is pressure in the atmosphere is greater than the pressure in the balloon and it starts to deflate. Okay, let's see if we can apply what we've learned so far. There's a question on the screen for you at the moment, and it says explain what would happen to the balloon if you took it to the top of Mount Everest. So the girl's got hold of it at the bottom of Mount Everest. If she was stood at the top of Mount Everest with the same balloon in her hand, how would the shape of the balloon change? Pause the video now and write down your answer, making sure that you explain the science behind it. Okay, so what have you got? Has it got smaller? Has it stayed the same? Or has it got larger? Well, the answer is it would inflate. It would get larger. You're not blowing any extra air in it, but it would get bigger. And the reason for that is the pressure of the atmosphere is going to decrease. So there's going to be less air pressure on the outside of that balloon. So what that means is there'll be a greater air pressure inside the balloon as a consequence, and that will push harder against the balloon and cause it to expand and get bigger. Well done if you got that right. If you didn't get that right, just think about it for a second and maybe you could help yourself by drawing a diagram of the pressure on the outside of the balloon and the pressure on the inside of the balloon to prove that it would expand. And to prove my point just a little bit further, the next time you're on an aeroplane, take a packet of crisp on the plane with you and put that packet of crisp on that little table in front of you. Yeah? And when that aeroplane gets to 33,000 feet, as high as Mount Everest, slightly higher than Mount Everest, see what happens to the packet of crisp. It should swell up and expand as the air on the inside of that packet of crisp begins to push against the packet. And another good example is this. A few years ago now, there was a gentleman called Felix Baumgartner, and he took a balloon up to the edge of space and then he jumped out of the balloon. And when the balloon was taking off, it looked a little bit like that. You see that? Right at the very bottom of that balloon, can you see the little capsule that he sat in? And the balloon is very thin and very narrow. And as that balloon started to go up, and eventually it got to 20 odd miles above the Earth's surface, the amount of air in or air particles starts to decrease, and therefore the air that's inside the balloon starts to push like mad and it inflates. And it looked like that at the end. Okay, a little experiment then for you to try to show the fact that air does have a pressure. And some of you will have already done this. Take a glass and in that glass fill it full of water. Make sure that water is right up to the top, even if it's just overflowing a little bit. The next thing you do is put a piece of card across or a piece of paper across and make sure you pat it down. Now, the next thing you need to do is you need to turn the whole thing over like that. But don't take your hand away immediately and make sure you do it either over the sink or outside or over the bath. Then take your hand away and see what happens. And hopefully you'll prove that air has a pressure great enough to hold that piece of paper onto that glass. And the reason that that would happen is because the pressure of the water pushing down onto that piece of paper would equal the pressure of the air pushing up, and therefore the air pressure will keep that piece of paper in place. Okay, so finally the work for you to do at home and the work for you to email to your teacher is this. Now in 1970 and in 1986, the FIFA World Cup of football was played at high altitude in Mexico. So the football pitches were really high up and they were much higher than the footballers are used to playing on. Now what I want you to think about is this. The question is this. Explain why there were more long-range goals scored in these tournaments than in previous tournaments. The footballers were shooting from all over and they were scoring lots of goals. Now when you think about air pressure, and see if you can answer that question. Well done everybody. See you next time.